Hello everyone, welcome to Let's Make Robots. So in this video I'll be showing you how you can create your first ROS workspace and how to create your first ROS package and then how to create your first ROS node. So this is a starting point for every ROS aspirant or every robotics aspirant who is trying to dive into robotics. So this tutorial assumes that you have already installed a robot operating system and Visual Studio Code and Terminator inside your machine. So if you haven't, please watch my previous videos which I have already included in this playlist. So go to my playlist and watch those videos, install those setups and come back. So right now I'm using a virtual machine which hosts an Ubuntu. And inside Ubuntu 20.04 I have installed ROS, the latest Noetic Ninja Miss version. So let's get started. So firstly what I'm going to do is I'll be opening Terminator, and inside Terminator let's view my folder. So inside Terminator I have created, inside my root folder I have created a folder named Let's Make Robots. So I'll go inside Let's Make Robots. So now I'm just trying to make a separate folder for all my work, so that's fine. You can also create in your root directory also. So what I'm trying to do is I will just type in mkdir p Catkin workspace, that's short for Catkin workspace, src. So what this command does is it will be creating two folders, one named Catkin workspace and another folder named src inside Catkin workspace. So once you hit enter, those two folders will be created, and if you type ls you can see Catkin workspace created, and if you cd into Catkin workspace you can see that src is also created. So move into src. So now we have our folder structure created. Now what you want to do is we need to declare this as our first ROS workspace. So what you want to do is what you want to type in is Catkin init workspace. So once you type in Catkin init workspace and hit enter, this entire folder structure will be made into a ROS folder structure. So you can find some extra files inside this. So in src you have cmake list, and yeah, so this is your first thing to do. Now as you can see, when we go inside Let's Make Robots, inside Catkin workspace, we can see that nothing is here. So from within this Catkin workspace we need to execute the command catkin make. So once you type in catkin make, it will start building all the necessary packages and it will create two folders, which is build and develop. So this build and develop is required for all of future scopes. So we'll type this command which will compile all our necessary packages. So we have typed in catkin make. So that's done, and if we type ls now, you can see that two folders are created extra. One is devel and other is build. So these two folders are created. Now what you want to do is, now everything is set up, like you have created your new workspace. Your workspace name is Catkin workspace. So I have just used a conventional name for this. You can create whatever it is, like your name underscore workspace or robotics workspace, whatever it is. You can name it anything, not a problem. So the next thing what we need to do is we need to source a particular file which is inside devel. So we'll just go into devel and see whether that file is there. So yeah, you see this setup.bash, we need to source this. By source I mean we need to include this in the bash rc file, so that each time you spawn up a terminal, all the commands required for that particular workspace will be already there. So we will just take this. So what you want to do is you need the path to this folder. So we'll just type pwd. Pwd will just give you the root until the devel folder. So inside devel folder we have setup.dash. Now what we're going to do is we need to insert this inside bash rc file. So for that I'll just show you how you can open up bash rc file in VS Code. So what I'll do is I'll type in code space tilde operator bash rc. So once you type this and hit enter, Visual Studio Code will open up your bash rc file for you. Yeah, so this is your bash rc file. If you remember, previously we have inserted another command. So this was inserted to terminal only. We tried echo insert and we have inserted this thing for ROS. So we'll just type here command ROS is it, this, and for the workspace we have new thing. So we'll type in source space Control V. So this will create an environment like a path for our environment, and we will just include setup.bash with it. Yeah, so now you have included everything that is required for your ROS workspace. So this is your workspace. Now if your workspace changes but it is still within the same folder structure, you can include that also by creating another source command. So that's it. You need to save it, Control S, and close this. Yeah, so that's done. And yeah, what is the next thing that you need to do? So now what you want to do is, so you have your cat in workspace setup now. Now the next step that we want to do is we need to create your first ROS package. So ROS packages are generally created inside src folder of the catkin workspace. So we will move into cd catkin workspace and src. So we will move inside this, press enter. So we are inside the src folder now. What we'll do next is we will type in the command to create a new package. So the command to create a new package is catkin create package, and then we will type in the name of the package. So right now I'm just going to type in tutorial package. So I'll type in tutorial underscore package, and next what you want to do is you need to define or declare the dependency. So here it will depend on standard messages, and it will have ROS by. So yeah, so the command will be like, wait a minute, I'll show it for you. The command will be like catkin create package tutorial underscore package. This is the name of the package that you intend to do. You can name it anything. And the next thing is dependencies, ROS by. So I'm trying to create my package using Python only, so I have included ROS by. But if you plan to intend C++, you can type in your ROS CVP also. So it all depends on you. So for now I'm just including ROS by, and I'll hit enter. So your new package is created. So inside ls src folder, if you type in ls, you can see that a new folder is created in tutorial package. So cd into tutorial package. Yeah, now you have another src folder inside this. So this src folder is inside which we will start creating our nodes. So we have this now, and the next step will be just to make everything work. We will move into the catkin workspace. This is not necessary at this step, but just to make things work, or just to make the compiler aware that a new package is created, I'll just catkin make this again. So inside catkin workspace, type in catkin workspace, and your new package will be recognized. So this is completely not necessary, but this is my way of doing it, so that's why. And move to src folder, cd into tutorials package. Yeah, now what you want to do is you need to create a new Python file. So inside tutorial package, if you type in code space dot, a new Visual Studio window will open up, which with your tutorial package folder previously loaded inside. So if you type in code space dot inside tutorial package and press enter, Visual Studio Code will open up, and yeah, you can find src folder here. So go into the src folder, nothing is there, so we'll type and create a new folder inside this. We will name it talker.py. So this will be your first ROS node, talker.py. So we will create that particular coding. So the first line would be a shebang command. So by shebang command I mean this thing. So you just need to type in user bin env python 3. So this just make sure that your script will be executed as a Python script. So this should be included in every Python script that you use. So that just to make sure that your script will be recognized as a Python script. And the next thing would be import ROSPy, and after importing ROSPy, so this ROSPy contains all the necessary functions and libraries that is required to create a node for ROS. So the next thing would be we will define our first function. So this will be the name of your node talker. We have defined a function name for that, and in the next step we will just declare our first publisher. So we'll type in pub equal to, pub is the just instance name of the publisher. So we'll type in pub and rospy dot, we'll call in publisher, the publisher's name would be. So now what you want to do is inside publisher you need to define certain parameters. So the first parameter will be the name of the topic. So topic means the channel through which you will be publishing your messages or your informations. You will get to know more information of it if you search on what is a ROS topic. So here you need to give the topic name. So I'll give here a topic name named chatter. So here chatter is our topic name, and the next thing that we want to do is we'll type in next thing that we need to do is define the type of messages that are being passed. So we'll type in string, and before you do anything, this string needs to be a standard ROS message type. So we'll import string from our standard message library. So we'll type in from standard messages dot message import string. So here string will be recognized. I'll just make this beauty. Yeah, so string is recognized right now, and we need to define the queue size, what is the queue size of that particular topic. So by queue size means it just make sure that you won't drop your messages, or you won't lose your messages in between if the subscriber side or the one who receives is kind of slow in processing. So you always need to define a queue size, because if you don't define, it will be considered as a synchronous type of communication, and it is not really recommended because it will always have glitches. So it is better that you define a queue size, and it should always be equal to or greater than your publishing frequency. So we'll come on to that later. So yeah, you'll type in your queue size here, and the next thing will be to like ROSPy dot. Next thing, we need to initialize our node. Here you have just initialized your publisher with this chatter publisher. Now you need to initialize your node. So you'll type in ROSPy init node, and you'll give your node name here. So your node name will be Talker. We'll give the name as Talker, and we'll give in anonymous equal to true. Oh man, typos. So what this actually means is, so now you have given a name Talker, right? So along with this Talker, if you type in anonymous equal to true here, it will just add some random variable over to here by creating a new node. So this makes sure that node to duplicate nodes exist, just so that every node will be unique. So if you type in anonymous equal to true, every node will be unique, and we won't have conflicts between nodes. So if I just create a Talker node and I didn't give this variable, means if I mistakenly create another node and I launch another node, this node will be like killed before the other node is launched. So that's why. So we'll just type in anonymous equal to true for this, so that the node name will be unique always. And the next thing will be to define the rate. Rate means rate is equal to ROSPy dot rate 10. So this is in hertz. 10 means the message will be passed 10 times per second, or your publisher will publish messages 10 times per second. So you can give it 60, which means it will publish 60 times per second, or you can give it 50, whatever it is, but for now we'll type in 10, and our queue size is also 10. So let it be like that. It just means 10 hertz. So yeah, the next step is to define a looping function which will execute again and again, and our messages will be published. So we'll type in a while loop, while not ROSPy. So you see that we have used ROSPy so much. I mean, ROSPy is very much acute with all the features that we need. ROSPy library. So we'll type in while not ROSPy is shut down. This means that while like this entire statement, like what we are going to type in below this thing, that will get executed until and unless someone try to kill a ROS core or try to kill a ROS node by pressing Ctrl+C or due to some other error. So until this ROSPy is shut down, this while loop will get executed again and again. So we'll continue writing. We'll type in our first string. So we'll create our string message. We'll type in this is my first ROS topic or something, and we'll put in timestamp also here just to demonstrate. Yeah, so this will be ROSPy dot get time. So this command will just assign the current time to this over here. So we'll get the time also printed. So this message variable now has this is my first ROS topic space the current time. So that will get stored here, and ROSPy dot log. So this is just for logging. We'll type in log info, which is like a message. So here what actually we mean is inside the terminal itself we can just print the actual message. So once we launch the node, it will start printing what messages is being sent. So we have rospy.log info, and we have passed the current message. And in the next step, what we want to do is we need to publish. So until now we have not published, like we have just initialized our first ROS publisher here, and we have also initialized our node. We have set the rate. No, we have just created the instance of rate. We have not actually used it. So we have just initialized the node, and we have set up an instance of a publisher. So now we need to publish. So we'll type in our pub.publish message. So now what will happen is our publisher will start publishing this message over the chatter topic. So I will tell you once again, like pub.publish means this publisher of ours will start publishing message on the chatter topic. Okay, so that message will be this. So the next thing will be to put in rate.sleep here. So rate.sleep comes from the rate instance here, and we have already defined the rate to be 10 Hz. So this means that while we have typed in rate.sleep here, this means that this loop will wait or sleep for a definite time such that only it will be executed 10 times per second. So this rate.sleep ensures that the entire loop is executed only 10 times per second. So if we just increase the loop here, the rate here to 20, this rate.sleep will adjust its sleep time such that this loop get executed 20 times per second. So we need this rate.sleep element here just to ensure that our publisher is publishing the our node or publisher is publishing the topic, not publishing the message only a definite number of times per second. So we'll keep this here, and the next thing is a generic Python thing. We'll call our main function here, type in underscore main. So we'll have a try catch here, no, try accept, sorry. So yeah, we'll call talker, and accept will be rospy dot ROS interrupt exception, and we will pass it. So yeah, so what this actually means is the ROS node shouldn't continue its execution once if the executed or the user decides to stop a particular node. So he'll just type in, or he'll press Ctrl C, and the node or our current node execution will get stopped here. So just make sure that it won't continue its operation after this statement. So we'll save this. So now we have a talker inside here. So we'll just see, we'll go to a terminal, and yeah, so I'll just clear my terminal. So yeah, I have cleared it. I'll just split this. You just right click and split vertically. Yeah, so now when we type in, we have this src here, and inside src folder we have this talker.py. So you need to make this talker.py executable. Then only you need to make your Python file executable. Then only your ROS or whatever it is can actually run your script. So what you want to do is you need to type in chmod u plus x docker .py. So yeah, now it is made executable, and we'll just see if the bash had already, or the terminal had already picked up our package. So we'll just try typing in ROS run. What was our package name? Tutorial. Okay, it hasn't picked up yet, so yeah, we'll try here ROS run. I think it was the old terminal. Actually, you need to spawn a new terminal in order for the changes to take place. So we'll type in ROS run tutorial package docker.py. Yeah, now you have everything set up. Now the thing with a Python file is you don't need to actually build or compile or run catkin make after every time you edit your code. So that is the advantage with Python, because as you know, Python is an interpreter level language. Every line is executed line by line. So here what happens is you don't need to particularly compile every time you edit your code in the case of a Python file. But if your code has C++ elements in it and you are coding in C++, definitely you need to run catkin make before you execute, before you test. So here we don't need that because we are using a Python file. So we'll type in, so we'll press enter here. Yeah, so yeah, so sorry, I have, so the first thing to remember is before you run a ROS node in ROS 1, you need to launch your ROS core. So we'll launch our ROS core here. We'll type in ROS core and press enter. So our ROS core is run. So in the next step, we will type in ROS run tutorial package. So this is the same command, ROS run tutorial underscore package docker.py. Press enter. So yeah, now you can see that our message is getting printed. So this is getting printed because we have given here log info. So this is the only reason why this is getting printed here. Okay, so now we'll try some experimentation. So actually we have given the rate 10, right? So as you can see, this is the speed at which it executes now. So we'll stop it. We'll type in Ctrl+C, Ctrl+Z, and the node has stopped. Now what we'll do is we'll try increasing the rate. Okay, we have increased the rate to 100 Hertz. So the next thing would be to run this again. So yeah, now you can see that the speed has increased. So now it is publishing at the rate of 100 Hertz. So yeah, stop it. I have just shown it to just make you clear on the idea about the rate and Hertz on the rate topic. So the next thing that we want to try out is like yeah, so we'll run our node again. Now an interesting thing to see here is, so if we type in ROS node list, you can see all the nodes that is running. So here you can see that there are 2 Docker nodes running, but one is definitely because we have like just tried to launch several nodes here, and the one hasn't actually stopped. So that's why you can see 2 Docker nodes here. So previously I have mentioned that, so we have only typed in Docker name there, and since we have just named this anonymous equal to true here, because of that only we are getting these random numbers. So just to make that variable unique, we have these random numbers here. So we have a ROS node listed, and the next thing would be we'll just list our ROS topics here, ROS topic list, and yeah, we have our chatter topic. So this was our topic. We have already given our name named what was it, yeah, chatter. So that's here. And if we want to see what the topic is publishing, we can type in ROS topic echo space the topic name. Our topic name is chatter. If we press enter, we will have our message here also. So you can see that the message is being printed, the same message. So the same message is being received by our echo script, and it is being displayed here. So now what we have done is we have just like echoed the topic, echoed what the topic is sending. So in the next video, what we'll do is we'll write down a subscriber for it. Like a subscriber will be subscribing to our chatter topic, and it will be printing it from the subscriber node, or like it will be printing it from its own node. So we'll see that in the next video. I hope you have understood. I have just increased the length of the video just so that you have a clear idea on this. So if you have any doubts, just comment down below, and yeah, we can have a discussion. If you would like to contact me, you can just go to Instagram and type in "Let's Make Robots." So yeah, that's it for today, guys. Bye.